Right. Are they
Okay.
coming in?
Just a second. As soon as you get it going, it's uploading the link.
They're coming in.
All right, go for it. Let them in.
Hi, good afternoon.
All right.
All right, you see them? Yes, they're right here.
Hello, everybody. Welcome to Destination Space 2022. We do Destination Space. We careers that you can have here in Silicon Valley, but everywhere in the US or wherever you want to grow up and be a professional. We want to bring awareness. So I'm inviting a bunch of my friends to come and tell you all about what they do at work and how they everyone in our community. That's a way. You can even come visit us. We're only like 10 minutes away from everyone connected. Right? We've already talked to you about Perseverance, our Mars rover, and Ingenuity, the helicopter going back to the moon. But today we have a very special guest. Today we have a marine biologist with the from studying Arctic whales to corals in everywhere that's wet and salty animals. Last week I was with manta rays, stingrays, and it's the work that he studies migration and behavior of the largest animals on our planet to develop new ways of monitoring why do they go there, and all this in response to climate change. Everyone, please help me welcome Mr. Jacob Levenson. He's going to talk to us about the secret lives of ocean giants.
I'm going to go ahead and share my screen here.
Yes, welcome, Mr.
Okay, Mr. Levenson, please go ahead.
Thank you, Andreas. It's always fun to get to share some of my work.
Yes.
Can everybody hear me okay? I just want to give me a thumbs up or something. All right, great. Well, thank you. Everybody can see my screen okay? This giant fish there. Thanks for having me. And it's nice to have a chance to share a little bit about what I do, studying some of the largest animals on Earth. So I'm a marine biologist, and I spend a lot of my time understanding where animals go and what they do. And so we can make better plans on how we use the ocean so that it doesn't impact large and endangered species. And so basically, I work to unravel the secrets of our planet's largest animals. And it's a kind of funny story on how I got in to do what it is I do. So I work with and I'll tell you a little bit about that in a second, but I work as a marine biologist for the Bureau of Ocean Energy Management. I kind of think of us like the Department of Dirt. We're part of the US government, and if you want to drill for oil in the seafloor or put a turbine, like a big renewable energy turbine, like you see here in this slide, if you want to anchor that in the seafloor, or if you want to suck up sand to restore a beach, you have to go through our office for the environmental review to make sure that everything is okay. But the way I got here was kind of I don't know, maybe a little unusual. I might be one of these kids whose parents went to the zoo and aquarium one too many times as a kid. And when I got the chance to go on school trips or things like that, I would always take that opportunity. And so what you see here is a picture of, on the top left there is me and my dad and me and my aunt at the New England Aquarium in Boston when I was, I don't know, 3, 4 years old. And little did I know that later in life, I'd go back there 13 years later as a teenager and start to work there as a volunteer, doing presentations about penguins, like what you see on the top right. And even as an aquarist, as a biologist, taking care of lobsters and other animals there at the aquarium. So I really sort of was one of these people that was just obsessed with marine life. I had a lot of fish tanks at home. I was just obsessed with it. And so, we often take it for granted, but, even though they call our planet Earth, it's really not. It's really a blue planet. Our planet's blue. And 3/4 of our planet is what makes our Earth inhabitable. And it's what makes it so that we can live here. So, my colleague Andreas that was just talking, what does he look for? What does NASA always look for when they want to explore a new place? They look for water. And that's because water is really important. It's critical for the existence of life to exist. And on our planet, Earth, we have lots of water. It's 3/4 of our planet, and it provides that ocean and that fresh water provides food for billions of people. It drives our weather, and it's even responsible for more than half of the air we breathe. So if everybody takes a big, deep breath right now, chances are a tiny animal called chlorococcus, it's hard to say, in the ocean helped generate the oxygen that you just took in. So the ocean is really important to how we live. And you know what? Most of the goods that we use, so if you're wearing a shirt or you're looking at your sneakers, chances are, even the components in the computers that you're watching me on, those all traveled by ship over water. So the ocean and the animals that live in it are critical to each of our lives. But the ocean's a big place and it's tough to explore. In fact, right now, there are probably more robots on the surface of Mars than in the deepest parts of our planet's ocean. And so what's amazing about ocean animals is really they grow to some amazing sizes. Like this leatherback turtle you're looking at here. This is on a beach in the Caribbean in Dominica. This is a fairly young turtle coming ashore to nest, and she's about 1,500 pounds, so a little less than a ton. And these are the world's largest sea turtles, growing to be about the size of a small car. And you know what? Aside from when the females come to nest every 2 to 3 years, we never see these animals. They never stop swimming their entire life. So, but to understand sea turtles, which is one of the big ocean giants that I study, you have to understand where they come from, because sea turtles have been around for a very long time. They've been around for about 150 million years, largely unchanged. So if you think about that, and this is going to be kind of blow your mind for a second here. If you think about that, they existed before the North American continent was in its present location. They existed before the Colorado River carved out the Grand Canyon. They existed long before humans walked upright or whales sang in the ocean. Sea turtles were out there swimming around. When the meteorite that extinguished about 99% of life on Earth, that led to the extinction of the dinosaurs, leatherback sea turtles, like that one in the previous picture, they survived. Leatherback sea turtles have existed largely unchanged from their present form in nearly 150 million years. There really are quite literally Earth's last living dinosaur, and we're lucky to still have a chance to see them. And it's funny, I like this little cartoon picture here because, there was a time when sea turtles would come ashore to nest, and they'd have to worry about dinosaurs like a T-Rex or something coming up and eating them. And so they'd kind of very carefully, peek their head out of the water, see what's going on, make sure the coast is clear, run up, lay their eggs, and run back down. Well, now they don't have dinosaurs to contend with. They have, lights and beach furniture and all sorts of stuff that we've just been around in the blink of a sea turtle's life. So if sea turtles have been around for 150 million years, humans have only been around for about 8 million years. So just think about that we're really like the new guys on the block compared to sea turtles. And they're pretty amazing. Despite the fact that they've been around for so long, turtles are really specialized feeders. And if you look at this face, this is kind of it looks like a dinosaur, doesn't it? If you look at the face of this leatherback turtle, you'll see they've got like a really specialized hook mouth. And that hook at the top jaw, let's see if I can point up with my cursor here. This right here, that's really important because sea turtles eat up to 300 pounds of jellyfish a day. And I shouldn't say jellyfish, I should say jellies, because they're not fish. They don't have fins or a backbone or gills or anything like that, but they eat 300 pounds of jellies a day. And jellies can be mistaken for plastic. Plastics and warming seas are some of the biggest threats that these animals face. And sea turtles face a lot of threats because they live life in the slow lane. They've been around for so long, they sort of play the long game here, and it takes a long time for them to recover. And from the moment a turtle is born, they accomplish some really amazing feats. Like a baby turtle is known as a hatchling, and it's just, it's the size of like a Pringles chip. It's just the perfect little snack morsel for just about everything in the ocean that wants to eat them. And after they hatch, they make a mad dash for the water. And what they'll do is they quickly look for any seaweed to hide around. After that, we don't really know where they go. In fact, we even call the first 10 or 20 years of their lives the lost years, because we don't know where these animals go. What we do know is that they likely spend their first years hiding among the rafts of seaweed, known as sargassum, floating around the ocean. So you can see the seaweed here, and they use that to hide from predators and just kind of follow that raft around the big ocean currents. But once sea turtles and other animals disappear from view, we don't really know what happens. We don't know where they go and what they do. And that's really where my job comes in. I use all sorts of different tools to look and listen for animals. And it's an important tool that tells us about animals and where no one can see them is called a satellite tag. So on the right here, you see a drawing of a sea turtle tag. It's just a battery and an antenna. It's pretty simple. And on the left is me attaching that sea turtle tag to a hawksbill turtle. We put a little bit of glue on their shell, and it lasts for about a year. The sea turtle might try and scratch their back off on some coral and break the antenna, but mostly it follows the turtle around for a year, so we can learn about where they go. And tags for turtles are pretty small. They're no bigger than like a cell phone, and a little antenna that sends a signal every time the animal surfaces. So here's a sea turtle being released in the ocean. Can you guys spot the tag? Feel free to shout. Can you nod your heads, whatever? Yeah, it's right. It's this little antenna sticking up right back here. So this is a turtle that was injured. It was rehabilitated at an aquarium, and now it's walking down the beach to go back in the ocean. And a lot of turtles like to scratch their backs on anything they can. And so they'll find a chunk of coral and rub their shell on it to scratch their back. And so can you see the antenna sticking on this turtle's back right here? I just circled it in red right there. That's the kind of tag that's really beaten up. And that's beaten up because the turtle is always scratching their backs and always kind of, finding little places to snuggle in at night amongst the coral reefs. Now, remember that giant leatherback turtle we showed in the first slide on the beach there? This is me attaching a satellite tag to that turtle at night. And it's not always it's not always easy to do this. You can see how big the turtle is compared to me. And these turtles are busy flopping, they're digging with their hind flippers in the back there. And so they're sending sand flying. And oftentimes you'll get sand in your face, like somebody's throwing sand in your face. And you're working at night, sometimes in the rain. It's not always an easy thing to do. But we can learn a lot from where these animals go. And so what you're looking at here is a map of the sea turtles. Each different colored dot is a different animal. So green is one animal. Sorry, my dog is barking. Green is one animal, blue is another, purple is another animal. And you can see they started off down here in the Caribbean on this little island called Dominica. And they went all the way up about 600 miles south of Iceland up here, and then all the way to the west coast of Africa. So they really are ocean migrants. They swim about 120 to 150 miles a day. And we use this information to make decisions. We can overlay all that data with things like oceanographic currents and other information, and we can start to see where the sea turtles and the threats they face might overlap in space and time. But not every animal I study comes to the surface to transmit. And so animals that breathe air are pretty easy. They come up, they take a breath, and you can put a tag on their back or on their head, and the tag knows when they're at the surface, and it'll send a signal. But some animals don't come up for air to breathe. And this is a great example. This is a whale shark. This is the largest fish in the ocean. And despite its name, it's not a whale, it's a fish. And they grow to be more than 30 or 40 feet. And there have even been whale sharks that have been reported to be nearly 60 feet. So really, really big. They can weigh more than 41,000 pounds. So think about that. A big school bus only weighs about 26,000 pounds. So they can weigh up to more than a school bus. And they can live to be very old. Some researchers have looked at how long they live, and it looks like they might be able to live to about 150 years old. So the world's largest fish. But not all sharks have big teeth. Even though we think of sharks like Jaws, like in the movie, whale sharks have really, really tiny teeth. But they've got a lot of them. They've got 300 rows of tiny teeth and more than 3,000 teeth. And a full-grown whale shark, like what you're looking at here, this is might be more than 5 feet wide. They're really big. Let's see if this video will play for you real quick. What you're looking at here, whale sharks will get together at places where there are a lot of fish. So this is a drone video, and watch as the drone gets higher and higher, how many sharks there are there. So what's happening is there are other fish that are spawning, that are laying eggs, and the sharks will detect that spawn, and they know to be in a certain space at a certain time, and they'll just sit there and devour all these fish eggs that are there. And so these, you can see here, there are probably more than 100 whale sharks in this video here. This is off the Al Shaheen oil fields in Qatar. But the same thing happens in the US, in the northern Gulf of Mexico. So imagine being around hundreds of animals that are all the size of a school bus. And whale shark, and for other animals like white sharks, we're still learning where they go. We don't really know a whole lot about their movements, and that they cross oceans. And this is a screenshot from an app called the Shark Tracker. This is a white shark that had a satellite tag on it, and she was tagged up in Canada. She traveled along the U.S. coast here, and then just decided, let's hang a left, and she just started swimming for the Mid-Atlantic Ridge. First time a shark's ever been documented. The Mid-Atlantic Ridge is a underwater mountain range that separates North America from Europe. And it's thought that there really isn't a lot of exchange over that, but this shark cruised right on over that. When you're one of the biggest fish in the sea, I don't think there's much that you can't do. Now, a lot of what I do, we can pause this for a second. A lot of what I do involves putting cameras on animals and understanding what they do on as well. And so you can see here, what you're looking at is a camera on the back of a whale. So this part right here at the bottom, you're standing on the whale's, basically on the back of the whale's head, looking forward. Up here is a bunch of tiny fish called sand lance, and right here are going to be some other whales that it's working together. And so using cameras that we attach to the backs of whales, we can start to understand how they work together. So we used to think that animals just dove down, grabbed a mouthful of food, and came back, but it's more than that. It's a lot more complicated. These guys are actually corralling food together. They're working together to make sure that no fish can get away. And then they open their mouths and create these big barriers. So let's play this for a second so you can see this. So there's another whale coming up right there. See how he's stretching along the sand? These are all tiny fish. There's another whale right there on the left. And there he goes. They gobble them up together, and they're working together so that all these, here are the little fish getting away right here. They work together so that fish can't get away, and they can really effectively chow down together. So you can watch that again here real quick. He's going to come up for air. There's his head up there. These are some of the fish that are kind of escaping there. Let's go back here. So watch this. There are 3 whales here working together. So here's one who's we're on the back of him. Here's another right here. And here's another right here. And you see how they're laying sort of like, if you don't want someone to get out of your reach, if you're playing tag or something, they're all working together to block off the fish so they can corral the fish together. And that's something we didn't know existed until we started putting tags on multiple animals at the same time. So let's see if this will play. And so when we put all this data together, all this information of animals, thousands of animals around the world with little transmitters on them, we can start to get an idea of how animals are moving around the globe globally. We really get to start to understand sort of the heartbeat of our blue planet. And so if you look here, you're seeing the thousands of animals that are tagged, and you're seeing their movements as directions over time. So we can see animals in the summertime migrating from the south up here to the northern latitudes in Europe and across Russia and other parts of the ocean here. And then as the seasons get colder, look at this. We're now looking at the migration out of Europe of birds. We're looking at seals going across the equatorial Pacific here. And we're seeing these massive migrations of birds to South America, of fish across ocean basins, of hawks and eagles and all sorts of things. And putting that together, we're really able to see how the entire planet is connected. It's not just one animal moving by itself, but we're all connected around the world. So our planet's changing a lot, though, right? So so understanding how animals move and understanding how they change related to weather patterns and climate change is really important. You need to know about this stuff if you're going to protect animals. And adding a layer of complexity, making things more complicated, is that our planet's temperature has increased by 1 degree Celsius over the past 150 years. And it's probably going to increase between 2 and 5 degrees Celsius by the end of this century. So one of the things that I'm working on, let's pause this for a second. One of the things that I'm working on is how can we find better ways to track animals? I am working with Andreas on a system of small satellites here so that we can have a sort of less expensive and easier and better coverage of our planet to track animals. These are using small things called cube satellites, these tiny satellites that are about the size of a coffee mug that we can use together to track things. And so I'll show you what it's like when those come out right up here. So here's one that's being launched from the space station. So what you're seeing there, you see these little satellites here? And so when I saw this, that's when I sent an email to NASA and said, hey, can we work together? Because I have a need to follow animals. And if you guys are putting these small satellites up there, maybe we can work together and do something really cool. And so that's how I connected with Andreas, and we're building a system and starting to test a better way of tracking animals when they go about their global migrations. So, I had a few things to put together here. I can keep talking, but if you guys have questions, I'm happy to answer questions or whatever. What works for you guys?
Yes, Mr. Jake. It would be nice if we start the questions right now. Would that be
Sure.
okay with you? Yes.
Yeah.
Because we have a lot of students raising their hand.
Okay.
Yes, here we go.
No problem.
Start raising your hand. I have Antonio first right here. Antonio, ask your question.
How many animals have you put cameras on?
That's a good question. How many? Oh, I'm going to grab one right here. I've got a camera. Oh, no, I don't have it. Sorry. I thought I had a camera tag right here. How many animals have I put cameras on? I'm not sure. At least 8, maybe 9. It's not just a camera too. It's listening for the sounds they make and the sounds that they hear, and also how they move. So every step they take or every flipper stroke they make, it's recording all that stuff a bunch of times a second.
Thank you, Antonio. Okay, we have another student. Nico, go ahead, unmute. Nico.
What's the biggest project you made?
Oh, I didn't hear that. What was that?
Nico, can you repeat the question?
What was the biggest question you made?
The biggest fish I've tagged, is that if I heard you right?
Yes.
Okay. The biggest fish I've tagged was probably a whale shark. Whale sharks are the biggest fish in the sea. And so I tagged a bunch of those in Mexico a bunch of years ago. And I don't think I've seen a bigger fish since then. They were huge, like 40 feet.
Thank you. I see Stephanie. Go ahead, Stephanie, ask your question.
When were turtles discovered?
Oh, when were turtles discovered? I don't know. I think the better question is, when did turtles discover us? Right? Because think about it. Turtles were here before people. So people probably showed up and they were like, hey, who's this new guy? But I don't know when people realized that there were turtles around. That's a good question. I don't know.
Good question. I see Miss Paulina's class. Let's see, Miss Paulina, who wants to ask a question. Go ahead. Go ahead, Miss Paulina.
Can you say it again, Fatima? So Fatima's asking, how many sea animals do you think there is in the ocean?
Oh, wow. That's a hard question. How many animals are in the ocean? You know what? I don't know if anybody has an answer to that, because almost every time we do a research cruise in the deep sea, we discover a new species. Almost every time somebody does a study of bacteria and in the ocean, all these living things, we discover something new. In fact, more than 90% of the ocean hasn't been explored. And so I don't think we really know how many animals are in the ocean.
Wow. Thank you, Mr. Jake. Let's see, just two more questions. Thank you, everyone, for being so patient. Jesselina, go ahead, Jesselina, ask your question.
What's the smallest ocean animal you've seen?
Oh, that's a great question. Smallest ocean animal I've seen. I've seen some shrimp and little tiny isopods and things like that are microscopic that you got to look at under a microscope. You know what I've always wanted to look at? There's a type of seahorse, a dwarf seahorse. If you look them up, they're the cutest things. They're like the size of your pinky nail, but I've never seen one of those. I really want to.
Okay, one more. Wow, we have a lot of questions. Everybody is so interested. Let's see. Mabel, go ahead, Mabel, ask your question.
What is the largest animal in the ocean?
Oh, that's a great question. The largest animal in the ocean. So, largest animal with a backbone would be a blue whale. And those can be, more than 100 tons, 100 feet long. They are huge. But there are other animals that are really big that live together in colonies, right? And so a coral reef could be huge. It could be miles long. And those are all tiny, tiny animals all living together. So it depends on how you think of it, what an animal is. But a blue whale would be my vote.
Okay. Thank you, everyone. Wonderful. We're running out of time. Thank you, everyone. If you have more questions, we're going to be doing this again next week. And I want to show you, Mr. Jake, can you stop sharing so I can show them
Absolutely.
For the next week? But before, we'd like to say thank you to Jake Levenson. Thank you so much. Let's all give him a round of applause. Thank you so much for having us here, listening to all your wonderful presentation. This is so valuable for our students, for Alum Rock, for you to be here. Thank you so much. Thank you, teachers. Thank you, students, for participating in this wonderful Destination Space 2022. And yes, we're doing this because of our students. Mr. Andres Martinez, I believe he's out of town, so we're sorry for the audio a little bit, but we want to just let you know, thank you so much for participating. And Jake, thank you. So I want to show you what we will be sharing for next time. We will be sharing with Mr. Quiroz. So let me show you which one this is. Give me a few seconds. Here we are. We want to make sure that you can see this. Let's see if this is the correct one. There you go. So this is Mr. Jake. He just finished this presentation. Next week, we will be doing Celebrando Planeta Tierra, because Mr. Quiroz is the weatherman for Telemundo, the Spanish-speaking channel. And so he will be doing it bilingually in English and Spanish for us. Okay? So thank you everyone for participating. And yes, keep all your good questions. Ask your teachers also. And then we will see you next week. Okay? Thank you, everyone. Thank you very much. Have a wonderful rest of your day and keep doing your